All right, so what is the difference between speed and velocity? Okay, you've probably heard velocity here and there. Oh, the velocity on that ball was huge. Well, what does velocity mean as far as physics is concerned? Because there's a lot of real-world changes to the meaning. So let's talk about what it actually means. And this is going to be a quick one, so you're in luck. All right, so first of all, velocity is, well, it's actually basically the same thing as speed. So in the sense that it is how fast you're going, except you add what direction you're going. Okay? So velocity is how fast you're going and in what direction. So you can't just say, oh, I'm walking at 1 meter per second. That would be your speed. Your velocity, so okay, so you could say your speed is 1 meter per second. But if I asked you for your velocity, you would have to say something like, I'm moving 1 meter per second, I don't know, to the south. Okay? Or something like that. I'll talk more about that soon. So, another way of defining it is the rate at which you move a distance in a particular direction. Okay, the rate at which you move a distance, that's that whole idea of speed being distance divided by time, except now it's velocity is distance divided by time, but it's in a certain direction. Okay? The most easy way to say this, though, is velocity is speed and direction. Okay? That's it. It's just speed, but with a direction. That's all it is. Okay? So, an object's velocity. How is that different than speed? Again, the only reason is it includes a direction. That's it. It just tells you where you're going. Therefore, this is where a little vocabulary comes in. It's known as a vector. Okay? What's a vector? Well, actually, the guy from Despicable Me actually talks about it correctly. He says that he is magnitude and direction. I should have a picture of him flowing up here, but that's okay. A vector is a quantity, like velocity, that has a magnitude or a size, okay, and a direction. That means it's got, oh, I don't know, let's say 1 meter per second. That's the magnitude. 40 miles per hour. That's a magnitude. But it also has the direction added in. So that would be 1 meter per second, I don't know, south, or 40 miles per hour to the right. Okay? Those are all directions. So if you're just looking at this part, you're looking at speed. But if you're looking at all of these together, okay, either 1 meter per second south or 40 meters per second to the right, you're looking at velocity. Okay? So what does this look like written down? Well, I actually showed you a good bit already, but let me show you again. For example, you could do 40 meters per second, and then here's what we do. We put brackets in. Okay? And let's say something's moving 40 meters per second to the east. We just put in a capital E for east. Okay? If it was 10 kilometers per hour to the west, we would do bracket, west, bracket, not parentheses. That's something different. You could even go a little bit further and say, oh, I don't know, maybe something's moving 2 miles per hour. Okay? But in this case, let's say it was a special case where, let's say, if we have a little compass here, okay, and you've got, let's see, north, east, never eat soggy worms, okay? And let's say this person is going, I don't know, this direction. Okay. And let's say this actually makes a 30-degree angle. Okay. What you could do is you could write this. Okay. Let's say this was 2 miles per hour. You could write that he's going 2 miles per hour, and then his direction would be 30 degrees north of west. Now, we're not going to get super into that. That's just sort of a side note, just to kind of take it a step further. Okay, so don't worry about it. You're not going to have to do this in conceptual physics. But other examples could be, I don't know, let's say 8 kilometers per hour down, or maybe 16 meters per second to the right. Okay? The key is you have your magnitude and your direction. You've got your magnitude here and your direction in brackets. That's what makes this velocity and not speed. Okay? Now, how do I actually find the velocity of an object? Well, here we go. Velocity, remember, it's basically the same thing as speed. So you've got velocity equals, well, it's the distance divided by the time. That's all. But you have to add the direction in there. So take out your essential equation sheet. Now, this is what you want to write down. Okay? You want to write down that velocity is distance divided by time, but then add a little dir to remind yourself to add the direction in there. Now, if we solve these algebraically a little bit, we can find different flavors to this essential question. Okay? Sometimes I won't give you distance and time. Maybe I won't give you distance, and I'll expect you to find the distance that you travel based on the velocity and the time that I give you. So let's do a little bit of algebra here. Let's see. V equals d over t. Let's say I want to solve for d. All right, what do I have to do? Well, I have to multiply both sides by t. Okay. So the t's cancel out. And what I'm left with is d equals v times t. There's another essential question. There's two of them. Two essential questions. Okay. This isn't a variable. This is just something to remind you that there's a direction. There's really no place for it in the equation, but I put it in there so you remember it. All right, let's do a little bit more algebra. If you had d equals vt, and let's say we want to solve for time, how long it takes based on velocity and the distance that you travel. What do I have to do? Well, I need to get t alone, so I've got to divide both sides by v. And what I'm left with is, well, v's cancel out, so I'm left with t equals d divided by v. And there's my last essential equation of this section. So, to summarize, you've got your essential equations here as far as calculating, and velocity is just the speed plus the direction. That's it. Make sure you write down a question for class tomorrow, and I'll see you then.